Shapes of distributions now. This is a histogram of a data set. Let's imagine there was 10 million data points, so we have this nice, perfect, smooth distribution. If I smooth this over, then instead of drawing the histogram, I can just draw the density curve. And if I erase the histogram, then we get a feel for what this looks like even without a histogram. And that's valuable because sometimes we can talk about what probabilities would look like even before we collect data, if it's like a theoretical idea. Now, this distribution has a shape. Some books call it the Dalek shape. That is not correct. This is called the normal distribution. If you want to give it a nickname, you should call it the bell curve. It's called the bell curve because it looks like the dress the bell wears in Beauty and the Beast. I totally made that up. It looks like a bell. We're not really creative with our names, okay? We're going to use this lots and lots in this class. Notice it's nice and symmetric. It has an area with high probability. That probability tails off. Technically, it never ends, but I didn't want to draw it once it gets so flat, because come on, what's the point? If you want to go the extra mile, you can even graph it. You can't see that in red. But that's not really required for you to know for this class. Only the idea that this bell curve shape is called a normal distribution. Our next vocabulary term is uniform, which looks like this. Not to be confused with the TARDIS distribution, there's an area that has no probability, and this area all has the same probability. The most common example is waiting at the bus stop. You can't wait less than 0, and you know it's not going to be more than an hour because the bus comes every hour, but how long you're going to have to wait has an equal chance in all that range. That's called the uniform distribution because it is uniform probability within the range. Now, skewed distributions can be either right skewed or left skewed, and it matters, and you're expected to know which one is which, and it's really easy to get them confused. So let's take salary. A lot of people earn this low salary, and then there's a few people that we just hate because they're earning that way high salary. This is called right skewed. How can you remember this is right, whereas this is left? Let me give you some ideas. For one, I could write it on the right side because there was space there. It's called right skewed because there's outliers to the right side. And here there's outliers to the left side. Most of the grades are in this high range, and then there's a few students who have personal issues come up during the semester and they have low grades down there. Another way you might try to remember is if this was like a sword and you were going to skewer, somebody get it, skewer, you would skewer to the right or skewer to the left, whatever works for you. I once had a student tell me they remembered because it looked like it had been punched from the right, with someone saying, skew you, which I thought was a terrible thing that I would never record on a video. I'm going to have to make mental notes to delete that out. Point is, make sure you can keep these straight in your mind. Now, outlier is tricky because we don't want to give this exact math definition of what is an outlier, and as such, it's a little bit based on opinion. Here's my data points in this cluster here. If I put a dot right there, does that seem like an outlier? Well, no, there's another dot that's far out. What about here or there? So in this class, if there's going to be an outlier, it'll be here, where it's obviously way far away from all the rest of the data, because I realize there's a certain area where this is opinion. Right in here, do we call it an outlier or not? Well, you should know what an outlier is and what it means. Now, here's why it matters. If you go to the DMV, there is a chance that you can renew your driver's license waiting a very small amount of time. There will be nobody in line, or the line will move quick. But most likely, you're going to have to spend a good chunk of time in line waiting. And sometimes you wait a long time. And sometimes you wait 5 hours. And sometimes your next of kin isn't notified because you've been at the DMV way too long. So where are the outliers? This is, of course, skewed right. That means the outliers are way out here. Most of the data is in this range, a little bit here, and outliers are those people who waited 14 hours at the DMV because it was Sunday and they didn't know the DMV wasn't open on Sunday. I don't know why. The point is, the outliers are clear on this end. So, where is the mode? I hope you can see the mode. It's this tall spot, right? Mode is the peak of the mountain. Where will the mean and the median be? If you were to slice this up like a cake, where would you cut it so that you would get half? I'm eyeballing it here. I'm going to say somewhere right there, median. Notice the median followed the outliers a little bit because you've got a lot of data clear over here, not a lot of data over here. So the median is going to be to the right of the mode because our outliers are to the right. But the average will be even more. Where you have to go to balance these outliers, the mean is going to be on that side. And I may have pushed it a little too far. I'm looking up the screen and it looks like my lines should be in just a little bit. But the point is, the mean is going to follow the outliers more because it gets fooled by outliers. The median doesn't get fooled by stuff on the ends. It only cares about where the middle is. And the mode, we don't really care about. It's easy to find, but we're not going to do much with them for the rest of the semester. So for any of these, you should be able to tell where the mean, median, and mode would land. For the normal, they all land on the same spot. Uniform, it's symmetric, mean and median. Of course, what is mode when it's all flat? That doesn't even make sense. But right skewed, and if we did a left skewed picture, you should be able to say, okay, I understand how the mean will follow those outliers and where the median and where the mode would be.